local club. The cost of the trip is $540 each for 80 passengers, with a refund of $5 per passenger for each passenger in excess of 80. So let's see if we can write what the cost of the trip is. And let's start off by making a variable. Let's let x equal the number in excess of 80. Okay? So the cost of the trip to the local club is going to be $540 times 80 minus $5 times x. I got that right?
Mm-hmm.
In other words, if there's 81 people, they pay $540. The cost of the trip's $540 each for 80 passengers. Okay. With a refund of $5 per passenger. You know, this seems to be right. What is this number here? 8 times 540. Find the number of passengers that will maximize the revenue received from the flight. I got something wrong here. I'm not sure what. The cost of the trip is $540 each for 80 passengers. So if there's 85 passengers, are we charging them $540 each for 85, and then they're going to get a refund of $5 for 5 passengers?
That's what it sounds like, at least.
That's what you think it is? Then this equation isn't right, because this equation would be 540 times 80 plus x. Minus 5x.
Oh, yeah, that makes a lot more sense.
It does. So this is 43. Yeah, because otherwise there wouldn't be a maximum. Now, hold on.
Wouldn't that just end up being 535x?
Yeah, and if you took the derivative of that, you got 535, and that can never be 0. So I haven't set up the equation right. So if I'm understanding this right, I'm not sure I understand their wording here. I'm trying to figure out how it makes sense. In other words,
maybe it's 540 times 80.
Okay.
And then 80 times 5x? Or
Well, not if we let
yeah.
x be the number in excess of 80.
What if it was x minus 80? No.
And I don't think we can go with the original equation, because then the maximum revenue would come when x is 0. So it would come at 80 customers. But the whole thing doesn't really make a whole lot of sense. I guess if you had 82, the second case may make more sense. But why isn't the maximum revenue 1,000,000 passengers? In other words, there must be some number that maximizes somewhere near 80. And I'm not seeing it. I'm not seeing the equation we need. This is kind of similar to a problem that I used to see about the subway system in New York, where they could charge a certain price, but if they charged less, they got more people to come. And so you had to come up with an equation, and then you could maximize it, and maximize their total revenue. So we need an equation like that. I don't know. I'm kind of stuck. Let me let's come back. Let's come back.
That.
What's that?
If you click the help me solve this, it'll probably show you how to set it up at least.
Oh, help me solve this. Okay, let's do it. Yeah. Okay, so the unknown, if we let P equal just the number of passengers, so then our equation would be what? It would be 540 times P minus 5 times P minus 80.
You can keep hitting continue and it should show you.
So P minus 80, so write an expression for the total refund.
So you had it right, just it's 5p.
Why is it 5p?
Because everybody gets a refund if it's the number of passengers minus 80. Each one gets $5 back.
So if there's 85, it's 5 times 85 times 5? The revenue function, let's see if we can write a revenue function based on what they've given us.
I think all they want you to do is 5p squared minus 400p.
And then, so you think this is the revenue function?
Yeah, but they want you to solve it. So if you put it in there, we can see if that's right.
Well, I know, but see, notice that the 5p times p minus 80 is the expression for the total refund. So that can't be the revenue function. The revenue function has to be 540 times p minus 5p times p minus 80. To me, that's the revenue function. Let's see if that works. 540p minus 5p times p minus 80. Identify the domain of the function. The flight must have 80. Okay, so you have to have at least 80. What's this 80 here? Am I supposed to put like 50 comma and then 80 is the top end?
P is greater than 80.
So the domain, oh, so they need a greater than sign here.
Yeah, I think so.
Greater than or equal to. How do I do that?
Look on the toolbar on the left.
Yeah. So the first derivative is 5. Let's see.
Negative 5p.
So this is
negative
minus
10p.
5p squared minus 400 plus 400p.
So
And we still have a 540p. Well, so it'd be negative 10p plus 940 is the derivative. So P 94 customers is going to produce the maximum. So first of all, we want the derivative function, which is minus 10p plus 940. You saw where I got the 940?
Yeah.
Okay. And if we solve that, we get 94. And then R of 94 is, go back to the original function. So we want 540 times 94 minus 5 times 94 times 14. Oh, geez, I thought I was typing in all that time. 540 times 94 minus 5 times 94 times 14. 44,180.
$94. $44,180.
How come they're asking us these?
Alright, and then close, and then it'll give us different numbers, but
Okay.
how to set it up.
I got it. Okay. I see what you're doing. We could have done this on these other difficult problems too, huh? Okay, so the revenue function as a result of P in this case is what?
585p minus 5p times p minus 80.
Well, they don't change it up much, do they?
No.
So it's minus 5p squared minus 400 plus 400. So
going to be 85.
It's actually 985p minus 5p squared. Isn't that the revenue function? I'm surprised they accepted our answer before. So,
Well, no, because you have to take the derivative of it.
right, which is
So it should be 10p.
985 minus 10p. Now, there is a problem.
Isn't it just 85 customers?
If you divide 985 by 10, you get 98.5 customers.
Oh, yeah.
So now we have to decide whether 98 is better than 99. So,
Try 98 first.
exactly. In other words, we're going to plug it in. Let's see, this was 85 times, what are we going to apply? 98
Yeah.
minus 5 times 98, and that would be 18, right? So R of 98 equals 48,510, and R of 99 equals 48,510.
It's the same thing.
I know.
Hold on just 1 second, David.
Okay.
Sorry about that. Sorry about that.
That's okay. We're going to get 2 shots at this, right?
Yep.
Shall we try 98 first? Shall we try 99?
Yeah. Yeah.
I can't believe that. Are you kidding me? 48,510, huh?
48,510.
I guess when they said round to the nearest integer, that automatically meant round up. All right. We're good to go to 11?
Yep.
Ah, good. Finally some. Okay. Optimization problems. You want to try to write the function that you're trying to optimize, just like the last case. Okay? We're looking at this. And here's the river. And he has 2,200 meters of wire. How best to string it to maximize that area that's enclosed? What is the function for the area that's enclosed? Let's assign some variables to this. How about the length and the width? So the area is what?
Width squared.
No, just width times length is the area. Whether there's a river there or not. Right. 2,200 equals the perimeter. So 2,200 equals what?
Width plus length plus width.
So 2 widths plus 1 length. Okay? Now, this is the way you want to kind of do all optimization problems. You want to define your primary function to be optimized, and then they give you enough other information that you can define a second equation in those same two variables, which means we can now define L as a function of W. So if I solve this first one for L, I get L equals 2,200 minus 2W. And then if I go to my area function and plug that in, I get W times 2,200 minus 2W. You see what I'm doing?
Yeah.
Okay, and that's what we want to take the derivative of. Set it to 0, and that'll tell us what W is. So A of W is 2,200 W minus 2W squared. A prime of W is 2,200 minus 4W. Set that equal to 0. And solve. W equals 550. So if we go back, this is 550. This is 550. That's 1,100, so this is 1,100 up there. So the maximum area of the rectangular plot is equal
605,000.
So I want to put an equal here.
I think it just 605,000 there.
605,000 there.
What's going to go here?
Click meter squared.
Meter squared.
Ah, okay. I'm sorry. What was that number again?
605,000.
605,000.
And what is that? It's meters squared.
Yeah.
All right. The length of the shorter side of the rectangular plot is 550 meters. Length of the longer side is 1,100 meters. Next problem. f of s is equal to 12s to the 0.25 if the maximum sustainable harvest, okay, so to find the maximum of that function, we want to take the derivative, set it equal to 0. What is that?
So it's one. It's technically it's 12s to the 1/4.
Right. So it's going to be 3s to the minus 3/4.
3/4.
Problem is there's no value of s that makes that equal to 0. But what is this? This is 3 divided by s to the 3/4. Well, 0 makes it undefined. So f of s is the maximum sustainable harvest. And we don't know what s is. It's just measured in thousands.
So would it be 2,500?
And you're coming, where are you getting that?
Just to make the 3/4 equal to 1. So it would be 1/4, and then I just kind of said that was 2,500.
I'm lost.
Yeah, me too.
Okay. Should we do the help me solve it? Because I'm missing something here. I got a feeling we got to come up with a different function. I'm just not sure how we're going to do it. 12 times s, they don't tell us what s is. Is s the maximum sustainable harvest?
It must be, yeah. Yeah, it is.
Yeah,
Well, no,
is.
because that would make it a billion, right? I need, unless you have an idea here, I'm going to have to hit the help me solve this. We'll be able to do another one similar to it, I guess, right?
Yep.
Yep.
I knew we were missing something. But wow, I'm not sure I would have figured that out from their information. So that is not the harvest function. Somehow they had this formula here. Any idea how they knew that? I mean, how is the harvest function equal to the maximum sustainable harvest minus the, I guess S is the amount that you're going to harvest. I don't know. But this is pretty clear that this is 12s to the 1/4. So our derivative was three s to the negative 3/4 minus 1.
Wouldn't it just be that?
Just be that.
Well, if we take the derivative of this function, we have to take the derivative of s also, and that's minus
okay.
1.
Oh, okay.
So if I set that derivative equal to 0 and solve for s sub 0, well, let's see. What do I get? I get s to the minus 3/4 equals 1/3, which means 1 over s to the 3/4 equals 1 over 3. So s to the 3/4 equals 3. So s equals 3 to the 4/3. Three raised to the 4/3. 27. Before we do this, I want to make sure that, okay, so we know, I do not understand, nor would I have been able to figure out, that it says remember. They must have gone over a harvest function in class or something. Because remember that h of s is equal to f of s minus s? I don't understand that, but I guess we don't need to.
Yeah.
That's what I did. I added the constant, divide by the coefficient, raise both sides of the equation to the reciprocal of the exponent. I raised 3 to the 4/3 power.
Is it just 3 to the 4th power? Or would it be 81?
Okay, here's the problem I had. The derivative was 3s to the minus 3/4 minus 1 equals 0, so I'm going to do that. That's what they said. Add the constant, divide by the coefficient. And now raise each power to the negative 4/3. The reciprocal is that is negative 4/3. So it's 1/3 raised to the negative 4/3, and that's 27. That's the same as this. 1 divided by 3 raised to the negative 4/3. And that's 27. Why does it say approximately?
I don't know.
I don't know.
Something's raised. How can that be 27? I'm doing something wrong there. In other words, this means 1 over s to the 3/4. So I should have s to the 3/4 equals 3. How is s equal to 27? How is 3 raised to the 4/3 power 27? That can't be. Here, let me do that again. 3 raised to the 4/3 power. 3 raised to the 4/3 power. That's
I
3.
think it's doing,
It's raising it
it's
to the
doing,
4th power. I need parentheses there.
yeah.
Okay. So the answer is 4.326. $4.327. Okay. 4.327. So I need 3 times 4.327 raised to the negative. Hold on. Sorry. It's 12 times 4.327 raised to the 0.25 power minus 1. All right?
Mm-hmm.
That's the harvest function. So now we've got 16.307. Harvest function is that minus s, not minus 1, minus s, 4.327. So now it's 12.980. Okay. So we know our harvest function is this thing minus s. All right, for the next one. So 4 raised to the 4/3 power.
I can do it really quick on my calculator.
Okay. The nearest
6,000. 6.3496.
6.350.
Yeah. Four to the 4/3.
$6.3496. That's 3.350, is it not? I do my math correctly here? Added 1 divided by the coefficient, so we got 1 over s to the 3/4 equals 1/4, which means s to the 3/4 equals 4. So if I take both sides to the 4/3, I solve for s. It's 6,350. No?
Yeah, because you did a decimal.
I did do a decimal. I don't want that decimal, huh? God. No, S is measured in thousands already. So I want that decimal. A quarter of 16 is 4. Surely that 0 isn't hurting anything, is it?
Maybe it's, yeah, 635,000.
Correct answer is 19.049.
Public service turned it on for a bit, remember?
Now, what are our options here? Just go to the next one? Or
Yeah, similar exercise.
and that'll let us redo 12?
Mm-hmm. Yeah, well, so you just have to...
I cannot see what we might have done wrong here. We took the derivative of that. You got a quarter times 16. Isn't that 4? It is. So it's 4s to the negative 3/4. minus 1, because the harvest function is f of s minus s. Take the derivative of s, you get 1. I'm doing exactly the same thing we did before. Help me solve this? Will that help us?
It'll just show us the same thing
that we went through.
I know it, but what? Remember that h of s, so the harvest function is 16s raised to the 0.25, right? Take the derivative of s, and that's equal to 4s raised to the minus 0.75 minus 1. You have a calculator?
Mm-hmm.
Take that number they had, 19, and take it to the minus 0.75 power, multiply it by 4, and see if that's equal to 1.
Nineteen to
To
negative
the negative
0.75
times 4.
times 4 equals
times
0.4359.
0.4359.
See, that doesn't equal 1. I'm not sure how they came up with that 19. We set the derivative equal to 0, solve for s. What was my first answer? 6.350? 6.350. Now it says it's correct.
Oh, we forgot to plug it back in.
Oh, that's what they were asking for, the maximum sustainable harvest. Okay. In other words, they weren't looking for a value for s sub 0. They were looking for that. Is there any point in us finishing this, or can I close it? And let's do a similar problem so we can get beyond. There's no point in us doing this math, right?
Nope.
We don't get any credit for this. Okay.
And then just click similar.
Okay. So the harvest function is the derivative of the harvest function is 5 so we have take 5 to the 4/3 power. What do you get?
8.5498.
Again, they give you this weird number. So now we have to take h of that number. And that's going to be our answer. So we want 20. You want to do this? Or should I do it in alpha, Wolfram alpha?
It equals 25.649.
What's the digit after the 9?
6.
6.
So it's 650. 25.650.
Mm-hmm.
And that you plugged in, you found H of 8.5498, right?
Mm-hmm.
25.65. Onwards. Okay, let's see if we can figure out a cost function. A cost function based on the number of cases. We'll do a cost function of C, where C equals number of cases that we're producing. Okay, so it cost $8 to store 1 case for 1 year. Wow. So the cost based on the number of cases is what?
33 plus
8 times C per year would be 8C
plus 33
plus 33. Is it?
plus
That's 33 to
7.
the setup cost to produce each batch. And 17 to produce each case. Plus 17C, is that what you said?
I think
So
so.
that's
Yeah.
our cost function. So that's 25C plus 33. Now, to minimize cost, it's going to be 19,008 times C I'm stuck here.
Mm-hmm.
Mm-hmm.
Should we help me solve it and then we'll do the similar one?
Let's just go to the next question.
Let's go to the next question.
14?
Yeah.
Yeah.
It's the same thing.
Similar kind of question. That's why I think we want to go back to 13 and see how they solve it, and then we'll be able to solve it. In other words, what we're having difficulty with is, can I just hit 13 here?
Yeah.
Yeah.
I want to see how they set up this equation. We may have to do it with both of these. These are tough setups. Okay, to find the number of cases per batch that should be produced, find the lot size that minimizes production costs. Well, how are we supposed to know this?
I don't know.
No wonder I can't figure these out. I'm not knowing these equations that they presume we know. That's very peculiar that they would expect us to know this. Q equals the square root of 2 little f big M divided by K. Doesn't it seem like they should have given this to us in the stem here?
Yeah.
Okay. So Q is the number of units in each batch. F is the fixed setup cost. K is the cost of storage, the cost of single. So let's see if we can plug in some numbers here. So Q is the square root of 2 times the fixed setup cost to manufacture the product, $30, times capital M, the total number of units produced annually, I think we're supposed to put in 6720 here? No,
Yes.
yeah.
I guess.
They have a steady annual demand for 6720 cases. The total number of units produced annually, I can only think we're supposed to put in 6720 there. And we're going to divide that all by K, the cost of storing, $7 for 1 unit. So all that's divided by 7. So that gives me the number of units in each batch. Do we have a number for this?
I can get it.
And then make sure you take the square root of it.
240.
Exactly.
Yeah.
So to find the number of cases per batch that should be produced, find the lot size that minimizes production costs. Well, production costs the cost of production as a function of U or of Q is the number of units in each batch. And we know that's 240. Okay, so F was 30. K was 7. Where G wasn't in this thing, was it? G is
No,
not
that's what I was
part of the
wondering.
equation for the
No, that's what I was
batch.
wondering.
Oh, okay. So G is 7, right? No. 19 is G. $19 to produce each case. Cost of manufacturing a single unit of the product. So that's
yeah,
got to
yeah,
be,
how many are
in a K?
well, that's got to be 19, isn't it?
Well, that's the cost, but it's
only
per
number-
unit.
Cost, but it's per unit.
Well, I think our unit here is cases. In other
I
words,
see what you're saying.
when they say a batch,
Oh, I
they
see.
mean some number of cases. So I think the cost to produce each case is a single unit of the product. Let's try 19. We'll find out soon enough. And M is 6720. All right. So 30 here. 6720 here. And 7 down there. All right. What'd you say the answer to that was? 240?
240.
I'm dying to figure out what their equation is that we have to take the derivative of. The manufacturer should produce 240 cases per batch. Find the number of cases per batch that should be produced.
So that's it. All you have to do is plug it
All you
in.
have to do is plug it in.
Well, and we didn't use the 19, did we? We didn't use G. We came up with that. Okay, so we're not done yet, I don't think. Yeah, we are.
No.
In other words, our
No,
answer didn't use G. It didn't use 19 anywhere. All right, let's close it and do a similar. The manufacturer should produce. We're not getting credit here, right? So I need to do what?
No, this is fine.
This is fine.
Is it the same numbers?
Same numbers.
240? Oh, no, it isn't the same number. No.
Yeah.
All right, so we need to fill in these numbers into this equation. So F was 10. This is 16.5. And K was,
K is the cost of storing per year.
so that's the 10. What was F?
Setup cost.
Setup
A
cost.
setup, so that's 33. What's this number? Let's see, we got the square root of 2 times 33 times 16,500 all divided by 10.
$330.
330.
All right. Business econ. I suspect that in business econ, you know all of these functions. At some point, they've given them to you. It's just they don't re-give them to you. for these problems. And I'm not going to know it for this problem either. So the way I see it, the only way we have of working through these is to do a help me solve it every time and let them give us the functions we need. Unless this maybe is the same function. Should we do that? Help me solve it and let them tell us what that function we're supposed to know is?
Yeah, because then I don't think if you put any numbers in, it doesn't change them.
Okay. Yeah. Look,
So it is.
see, this is critical information. Yeah. And it is different. And we don't know what all of these things are. Oh, I see. There's two Ks. There's two storage costs. So it actually is the same function. It's just that instead of being divided by K, there's a second storage cost, and for some reason we need to divide by the first one plus twice the second one. Okay. So F is the fixed setup. What is F?
F is the
setup cost.
Well, in our problem, what is F?
Oh.
743.
M is 35,664. K sub 1 is the annual cost for storing. She must pay annual warehouse fees of $2 per case for the maximum number of Ks. So it's K1 is 2, and K2 is 743.
No, I think.
We've got a bunch of numbers here that we haven't used yet.
Per case manufacturer
Is
is $8.
So that would be the G. So that's the number we don't need. So that $8 is G.
Case of 2 is 2.
So we've got a 2 and we got another 2. What about the 743?
That's F.
Okay, so we got 2 times 743. I'm still not sure what YK sub 2 is the same as K sub 1?
Well, it costs $2 per year in electricity to store, and $2 per case for the maximum number of cases.
So it would be 2 plus 4. So now we need that number.
$2,792. No, excuse me, 2,972.
Is Q, huh? Are we going to get to answer this one? Should we go through this one? Or see, once they've given us that equation, we don't need to do this anymore.
Yeah, you can just close.
Yeah, you can just close.
But let's make sure. I guess we should make sure we're right. Otherwise, we could be spinning our wheels all day here. 743 for that. 35664 for that. G was 8. K1 is 2. And K2 is 2. Let's check that. Okay. Now we can close it out. Okay, so this number becomes 747. This number becomes 29,880. And here we've got should have read those definitions a little closer. What's K1 and what's K2 here?
K1 is annual storage cost.
K1
K2
is annual storage cost. K2
each unit
is
up to the
each
max.
unit up to the
stored.
max unit stored.
So it's 1 and 2, or is it 2 and 1? Ah, it's 1 and 2. So we're dividing by,
Two.
it's 1 and 2, right? So we need this number here. All of this divided by 5. And if that's not the answer, it's divided by 4. In other words, if our 1 and 2 is reversed.
$2,988. Alright, try. Well, this, when you divide it by 4, it comes out as a decimal. 3340.685.
How are you getting that?
Well, you said
If
that didn't work, then divide it by 4 instead of 5.
So in Q is the number of production runs?
Yeah.
No, Q is the number of units in a batch.
No, Q is the number of units in a batch.
So what did this number come out to be again?
Divided by 5 or divided by 4?
Yeah, divided by 5. That was 2988.
Yeah.
So there's 2,988 units in a batch?
No, it's the number of
No, it's
production
the
runs.
number of production units.
So we have to divide that
We
by
have to
something.
divide that by something.
Try 10.
So
I think
And
it's
it's-
10.
just 10 as an answer?
Yeah.
Yeah.
I have no idea where you got it, but I'm completely lost. How'd you get it?
So I just took the...
29880 and divided it by 2988.
Yep.
Okay. All right, maybe we can figure this one out on our own without their help, using that same equation. I've never seen these kind of problems, to be honest with you. They don't involve taking derivatives or anything. In other words, they've got a straight formula. $6 to place a reorder. Don't know the equation they're looking for here. I suppose we could divide this by 6 and see what number we get.
All right.
All right.
$922, right?
K is supposed to be the fixed costs.
No, F is the setup cost.
If it costs $6 to place a reorder, what is this number?
That's 922.
Seriously? Oh, it's the square
Yeah.
root of 920. It's the square root of 920.
Oh, yeah. Yeah.
Yeah.
Which is
Which is
30.36.
30.36.
So we'll try 30.
Yeah.
Yeah.
Now my mouse is going crazy on me. Which it does every now and then when I'm using my cursor and my mouse. So we need this other equation they're giving us here. So does that mean we need... Since that was a guess, we can't assume that it's either 30 or 31, can we? Test each of them. We could test what T of Q is. It says, use this equation to test the integers on either side of Q. Well, the integers on either side of Q are going to be 30 and 31. So if we plug in 30 into here and 31, whichever gives us the smallest cost is the one we want to use. So T of 30 would be equal. The problem is we don't know if we have if we did it right or not. In other words, we don't know if k is 6.
Yeah.
Yeah.
I guess we can keep going. The answer is either going to be 30 or 31, right? Do I still have time to try 31?
Yeah, I would just type in 31.
Yeah.
I think
I
that'd
was
be right.
just typing 31. I think that'd be right.
All right. Which means we probably don't have the right numbers for Q, for determining Q. Our F and K might be different. They must be different. We're going to have to help me solve this on this one also, I'm afraid.
Well, if it's the same equation, then we just need to flip two of the numbers.
Maybe you're right. In other words, put the 6 up here and the 3 down there.
Yeah.
What's that number? That would be 4 times 922. The square root of 4 times 922.
Uh, 42.9. So the whole number, I would just do 43.
Well, are we going to get 2 chances? Because our answer is
No,
going to either be
yeah.
42 or 43. Well, we can figure it out. We got to plug everything into here. So we've got here. Let's 42.9. So we need t of 42 and we need t of 43. Okay, and here's what we got. We got F equals 6, K equals 3, and M equals 922. So T of 42 is 6 times 922 divided by 42 plus 3 times 42 divided by 2. T of 43 is 6 times 922 divided by 43 plus 3 times 43 divided by 2. Whichever of these numbers is smallest is our answer.
The top one is 194.7. Bottom one is 193.
So 43 is our correct answer, according to that.
Yeah, hopefully.
What odds would you give me? Ah. So, what do we really think F is? 3?
Oh no, this
This
different
one has different.
definition.
No, this is this. Oh, okay. So F is the fixed cost to place an order. That was 6.
So F is 6, K
So
is
F
3.
is 6, K is 3.
And there's 922.
And there's 922.
So, didn't we do that though?
Okay, so F was 6 and K was 3. Take the square root of 4 times 922 again. That is going to be about 60. I can see it because 4 times 9 is going to be 36. Square root of 36 is going to be 6 something. Let's take 4 times 9, 22, and then take the square root of that.
My calculator's being a pain. 60.7.
I can do it.
60.7, so 61.
60.7. Okay, so we needed to find t of 60 and t of 61 and find out whichever one was smaller, and it's clearly going to be the 61, which was the right answer. So let's do a similar exercise. Okay. Q is the square root of 2fm over k. And in this exercise, f is 10, k is 1, correct? And m is 892. So we want the square root of 2 times 10 times 892 all over 1. So what's the square root of 20 times 892?
$134.
Hold on a second. Just check that. We get 133. So we want to check one. I get 133.56. So now we want to do a t of 133 or t of 134. Do we get 2 choices?
Yeah.
Let's try 134 first. Great. Should we call it a session?
Yeah.
These are brain. These are hard because we don't know the equations underlying them.
Yep.
But they always give you a technique of figuring it out. Between the help me solve this, we can get every one of these right, I'm sure.
Yeah. And then just schedule in advance. Next Thursday.
Uh-huh.
I can't meet.
Okay.
So
So
just Tuesday from 6 to
just
7.
Tuesday? Yeah, let me pull it up here real quick. So this one we're canceling for this time only. I will see you at 6 on Tuesday.
All right. Thank you.
Okay? All right, Sean. Have a good one. Bye-bye.
You too.